Hello, engineers. Hope you all are doing great. In today's session, we are going to discuss how can we horizontally scale a DB server. How can we horizontally scale a DB server? Before that, before deep dive into this, we have to discuss what is meant by DB server. What is meant by DB server? So let's discuss this in details. Detail. DB server, right? What is DB server? When you install MySQL into your systems and you try running your application over this, what happens? What happens? You have a database. You have a database, right? Suppose this is your database. Now, what is database? Database is basically a physical storage of your data. It is basically a physical storage of data, but you have to make it capable enough of responding to the backend queries. You have to make it capable enough to respond to the backend queries. So what you do, you rent a machine. You rent a machine. Suppose this is the AWS machine, right? This is the AWS machine or EC2 machine. This is EC2 machine. Okay. You rented this machine, and what you do, you will deploy your database in this machine. You will deploy your database in this machine. So now, what this EC2 machine is, it's kind of a database server. It's kind of a database server, right? What this EC2 machine? This is a database server because it is hosting your database. It is kind of a database server. So if I try to write the definition of DB server, I can write that DB server is a machine that hosts your database simply, right? Now, DB server can be any. DB server can be any. It can be any EC2 machine. It can be any EC2 machine. It can be any EC2 machine. Like you create a database and rent a EC2 machine and deploy your database over this. You can have virtual uh, servers also, cloud servers also. That is, if you have ever used MongoDB, then you have something called MongoDB Atlas. MongoDB Atlas. What is this? It's again a database server. It's a cloud server basically, which is provided by MongoDB. Okay. Then you have something called Supabase. It is a cloud server for PGSQL. It is cloud server for PGSQL. Supabase is cloud server for PGSQL. And what is MongoDB Atlas? It is cloud server for your MongoDB. It is cloud server for your MongoDB. It is, or I can write cloud server for MongoDB. Okay, like you can have your own EC2 machine, deploy your database there, and simply that will become your database server. Okay, now the question arises, why do we need to horizontally scale this database? Suppose this is your database machine. This can be any EC2 server, this can be MongoDB Atlas, this can be Supabase or anything, right? How a typical architecture of a system looks like. We have a client, right? Client will request, then the request will go to load balancer. Then load balancer on the basis of some algorithm will redirect that request to any particular server presented. Active server, right? We have three servers here, server A, server B, or server C. Load balancer will redirect your request to any of the available servers. Then what this server will do? Suppose a request was redirected to server B. What this server B will do? This server B will do it will query your database server, right? It will query your database server. Now, this database server is again a machine. It is again a machine. And if number of users or number of requests increases, it may crash. It may crash, right? So I can write it here. If number of requests increases, your DB server may crash, right? So we need to scale this. We need to scale this. And for scaling, how many approaches do we have? How many approaches do we have? We have two approaches. The first one is what? Vertical scaling. Vertical scaling. And another one is what? Another one is horizontal scaling. Another one is horizontal scaling. Horizontal HRI. Horizontal scaling, right? We have already discussed about vertical scaling in our last video. Today in this video we are going to discuss horizontal scaling aspects, right? Before actually discussing about horizontal scaling, we have to discuss something called DB partitioning. We have to discuss about something called DB partitioning. Let me write it here. DB partitioning. DB partitioning. So what DB partitioning is? What DB partitioning is? DB partitioning is, let me write the definition first. DB partitioning, we can say it's dividing your data, dividing the data, dividing your data and finding out some strategy to store it, and finding out some strategy to store it, to store it. What is meant by dividing your data? What is meant by dividing your data? Let's say this is my table. This is my table. And let's write its name as, this is order table. This is order table, right? It will have millions of rows. It will have millions of rows, right? Let me create few rows here. Right? It can have billions of rows, and million or billions of what we say rows, right? We can write it here, right? It can have millions of rows, right? Now, if I query it, if suppose my query looks something like select star from orders where order date can be any attribute of this is greater than or equals to, we can write any date here, suppose 2026 and 11, right? If I write this query, if I write this query, right, what will happen? What will happen? The whole order table will be scanned. The whole order table will be scanned, and the wherever the order date is greater than or equal to this date, those rows will be written. Those rows will be written. So what is the time complexity here? It's order of n. It has to scan all the rows present in it, right? So what is DB partitioning? DB partitioning is dividing this table into multiple creating multiple partitions of this table. Suppose I created a partition. Uh, we can copy this only. Okay, this is orders partition one. Partition one, and I created one more partition. I created one more partition. This is, let's say, partition B. This is partition B. Partition 2. It was 1 or A? Yeah, it was partition 1 and it is partition 2. Now what will happen? Suppose I have done partitioning on the basis of date range. On the basis of date range of this order date attribute. Of this order date attribute. Suppose this partition 1 holds all the orders with order date of year 2025. Of year 2025. 2025. And this partition holds all the orders of 2026, right? Of all the orders of 2026. Suppose it had 1 million rows earlier. Now this got partitioned into two partitions, right? Partition 1 and partition 2. Partition 1 holds all the data of year 2025 and partition 2 holds all the data of year 2026. Now, when I write or I try to execute this query, what will happen? It will check order date should be greater than equals to 1 1 2026 2026. So it will simply ignore this partition. Why? Because it holds records of 2025 only, and we want records of 2026 or 1 1 2026 and um after that. So it will scan the rows of this partition only, right? So what happened? The search space got reduced. Earlier we had to scan the whole orders table. Now we have to scan only a single partition of it. So search space got reduced, right? What other things we can do? Suppose we have multiple such queries, we can do parallel processing also. We can parallelly process this partition and this partition. This is one more advantage of this. So let me write the advantages of, or I have to change the font, silly font. Advantages of DB partitioning, right? What are its possible advantages? First advantage is what? First advantage is partition pruning. Partition pruning. What does partition pruning means? Partition pruning simply means that it is a DB optimization technique of skipping irrelevant irrelevant partitions and scanning only partitions that can that may contain the requested or required data. That may contain required data. What does it mean? It means partition pruning is a DB optimization technique. It's a DB optimization technique. What kind of technique? In this, it skips the irrelevant partitions. For this query, what was the irrelevant partition? This was the irrelevant partition. So it is a technique of skipping irrelevant partitions and scanning only partitions that may contain the required data. So in partition pruning, what will happen? It will scan only this partition for this query. So our search space got reduced. I can write it here. Search space gets reduced. What are the other benefits I can get? I can do parallel processing or parallel DB querying, right? I can do parallel DB query. Or what are the other things I can do? Let's consider Example, where we are storing logs. It can be any log where we are storing log in our table, right? We are storing logs in our table. Uh, it can be, suppose it's related to orders logs only. Okay. Now what will happen? Log may uh, like may pull your storage, your DB storage in a very short span of time. But we don't want any longer logs, right? Suppose it's related to some orders related log, and I want only logs of recent 2 years, year 2026 and 2025. I don't want logs of year 2024, 2023 or earlier logs. Okay. So what DB partition will help me in this is that I can easily drop those partition that holds the logs of 2024 or earlier years. Okay. That will hold logs of year 2024 or earlier years. I can easily drop those partitions. So these are the benefits of TV partitioning. But now you will ask me that we were going to discuss about horizontal scaling of DB server. But why are we studying this DB partitioning? So understand one thing. I have written here that it is dividing your data and finding out some strategy to store it, but it is always within the same database server, right? It is always within the same database server, or I can write it here as well in this with good colors, that DB partitioning always occurs within the same DB server. Within the same DB server. What does it mean? What does it mean? Whatever I have written here, what does it mean? Suppose I have a DB server. Let me select this. This is my DB server, right? This is my DB server. It may have multiple tables. It may have multiple tables. So whenever I am doing DB partitioning, what does it mean? I'm partitioning the tables inside this DB server into different partitions. I'm dividing the data of tables into different partitions or multiple partitions. But those partitions will remain within this server only, within this server only, right? So what if number of users or requests increases? We- Even we have introduced the DB partitioning, we have created multiple partitions, but those requests will hit this DB server only, this DB server only, and has it again may crash. Okay, so we have to horizontally scale it. We have to horizontally scale it, right? So what we can do? What we can do? Then something comes up that we call sharding. Sharding. DB sharding. Right. This is DB sharding. What does DB sharding means? What does DB sharding means? It means it means dividing dividing the data of same table across multiple DB servers. It is dividing the data of same table across multiple DB servers. In DB partitioning, what we were doing in DB partitioning, what we were doing, we were dividing the data of a table of the same table into multiple partitions, but within the same server. But within the same server. But what we do in DB sharding, we divide the data of the same table across multiple database servers. Across multiple database servers. Let me discuss it in detail. Let's see, this is my order table again. This is my order table again. This time, what I will do? What I will do? I will create a database server. I will create a database server. I will create a database server. Suppose this is one of my database server. This is DB server one. Okay. And and what I will do? I will divide the data of this orders table. I will divide the data of this orders table and deploy this in this. Deploy this in this. Okay. Suppose this DB server holds the data of year 2025. 2025. Okay. Now I will create another DB server. I will create another DB server. This will be a different DB server. This will be a different DB server or a different machine, not the same machine. It will be a different machine. It's DB server 2. It's DB server 2. And it will contain the data of the orders table, but of the year 2026. But of the year 2026. Now we have two database servers, or we can say two machines, two individually deployed machines. We can say these are two individually deployed machines that contains the data of orders table only, but the it doesn't contain the full data of orders table. Few of the data is present in this table, but few data is present in this server, not table. Few data is present in this server, and few data is present in this server. Few data is present in this server, right? We can write it here as well. Here we created two individually deployed DB servers that contains the divided data of the orders table on the basis of orders date attribute. Orders date attribute. So now the question arises: what is the basic difference between DB partitioning and DB sharding? DB partitioning and DB sharding. So let's discuss this here. Let's discuss this here. Let me create a kind of a table, a difference table. Right, this is a difference table. And here I can write DB partitioning. I can write DB partitioning here. DB partitioning. And here I can write DB sharding. Most people use these terms interchangeably, but there is a difference between them. DB sharding. Okay. In DB partitioning, data of a table is divided, but remain inside the same DB server. Whereas in DB sharding, what happens? Data of a table is divided, but it remains on the different DB servers which are deployed independently and individually. Right? This is DB sharding. Let's discuss a interesting example of Amazon. Let's discuss a interesting example of Amazon. Suppose what Amazon did do. Amazon, what Amazon can do that for every order, every order Amazon is receiving, they can consider the country, like people of what country is creating that order. Like someone may be from India, someone may be from New York or any other city, right? So suppose Amazon is getting orders of different cities. So what they can do, they can consider the countries of that respective cities, and on the country codes, they can do sharding, and they can deploy or store the country specific data into the nearest servers, into the nearest servers. Let's discuss this how. Let's discuss this how. Suppose this is 1 DB server that holds orders, details, um order details of East Asia. East Asia, right? East Asia. There is another server in which we store the order details of Europe region, right? There can be another in which we can store data of US, right? In this we can store data of what any reason, Middle East, right? Middle East countries. So what we can do, we can deploy this server where we can deploy this server in Mumbai. We can deploy this server somewhere in Europe. We can deploy this server somewhere in Europe, and we can deploy this server in US East, right? US East. And same way or likewise, we can deploy this server somewhere in Middle East, Middle East, right? What will happen this way? What will happen this way? Whenever I want to check my previous orders, whenever I want to check my previous orders or my order history, I will query the nearest server. Suppose I am currently sitting in India, so I want to check my details. I want to check my order details. So out of these four shards, where my data will be stored? My data will be stored in East Asian server. My data will be stored in East Asian server. So I have to query the server deployed at Mumbai. Deployed at Mumbai. So what will happen this way? What will happen this way? My network latency will be reduced. My network latency will be reduced. Okay. So if you want to understand DB sharding, you can learn or remember this example. You can learn this example, that in this example we can deploy the orders related data across multiple database servers which are deployed at different locations across the globe, which are deployed across the multiple location or different locations across the globe. So if I try to create a architecture diagram of this, I can create it something like, let me copy this only, let me paste it here, or what, this thing will remain same, this whole thing will remain same, but now, now we have, we have, this is our, let me write it here, this is our database DB infrastructure. This is our database infrastructure, and inside this, we can have multiple charts. Inside this, we can have multiple shards, right? We can have multiple shards. This is, let's say, shard Mumbai. This is shard Europe. This is shard Middle East. Or let me write it MS here. ME here. ME means Middle East. Middle East. Okay. And I can write it like shard East US. East US. Okay. East US. I have these four shards, four database shards. So now what will happen? What will happen? Let's consider this Amazon scenario only. Client will request will go to load balancer. Load balancer will redirect it to any available server, server A, server B, or server C. Now, when server B will request data or query the database, it will not query a single server. It will not query a single server. We have a complete database infrastructure. It will query any of the relevant shard. It will carry any relevant shard. Suppose the client is requesting data from India. Excuse me. If client is requesting data from India, it will simply query the Mumbai located shard. It will simply query the Mumbai located shard. What will happen? What will happen? This will we have actually horizontally scaled our database server. We have actually horizontally scaled our database server where we have created four different instances of it smartly. We have smartly created four different instances of it, and we can create more instances as well. We can create more instances as well. So this is what our horizontal scaling was. Horizontal scaling was creating multiple database servers or servers. So this way we created four servers here, right? And we created them in a smart way. If we consider this Amazon scenario only, we created it based on the country code, right? We create it on the basis of country code, or we can have any other mechanism also. We can create it on order number or any other scenario. But this is what horizontal scaling is. This is what horizontal scaling is. And we can say that each individual DB server within my DB infra is called what it is called. It is called shard. It is called a shard. It is called a shard. It is called a shard, right? What this basically is, what this basically is, this is a server, this is a machine. This can be EC2 machine, it can be MongoDB Atlas, it can be Supabase, it can be RDS relational database system provided by AWS. It can be any machine. This is machine A, this is machine B, this is machine C, this is machine D. We have deployed our machine, this machine in Mumbai, this in Europe, this in Middle East, and this in East US. And we have divided our order stable data such that data from East, South Asia or South Asia will be stored in this machine or this database server. Data from Europe will be stored in this database server. Data from Middle East will be stored in this database server. Data from US will be stored in this database server. And this each individual database server is called this individual database server is called a shard. This is shard A or shard Mumbai. This is shard B, shard C, shard D. This is my shard D. So this is horizontally scaling of a database, right? Now let's try discussing some of the challenges with it. Let's try discussing some of the challenges with it. Challenges with sharding. Now you tell me. Now you tell me. If Europe shard gets too much load. Okay. Now tell me if Europe shard gets too much load, right? If this shard is getting too much load, it may crash. It may crash. Or what if Asia or Mumbai shard burn out? Let me write it here as well. If Asia shard burns out, right? What if any of these four shards get crashed? It may be burned out. It can get over user load, over request, or there may be other scenarios as well. What will happen? We have to scale these individual shards as well. We have to scale these individual shards as well, right? So to avoid these cases, we have to scale these individual shards as well, right? As well, right? I have to, let's take Europe one. I have to scale this one. I have to scale this one. Shard Europe. How can I scale it? How can I scale it? Again, I have two approaches. Just tell me quickly what it be, what they are. First one is vertical scaling. And if I have written vertical scaling here, you might be aware or you are most probably aware of the another one that is horizontal scaling. Earlier what we were doing, we were scaling a individual database server. We were scaling our database server. We created shards. We smartly divided our data across multiple servers. Now, if that individual server also gets crashed out, if this individual server also gets crashed out, we have to scale this individually as well. We have to scale this individually as well, right? We have two techniques for it. First one is vertical scaling, another one is horizontal scaling. Now you all are aware what we do in vertical scaling. What we do in vertical scaling. It's about add computing resources. Like earlier we had 16 core machine. Now you can rent out 64 core machine, 32 core machine. You can increase its memory size. You can have a good machine, right? You can add computing resources, right? But there is always a upper limit to it. But there is always a upper limit to it, right? And about this vertical scaling, I have discussed in detail in my previous videos. One was about DB scaling, in which we in detail discussed about vertical scaling, and in my previous video also, where we were discussing about DB server scaling, we discussed about when we were discussing about DB server scaling, we discussed about vertical scaling. You can go and study about it. It's simple. Vertical scaling is pretty good, right? We can add computing resources, and if your complexity is not that too high, you can go for vertical scaling, right? But there is always a upper limit to it. And again, if you create a new shard, right? If you suppose earlier you had 16 core machine, now you rented 64 core machine. So now what you will do, you have to copy the data from your earlier shard to that newer shard, that again a complicating kind of thing, right? So we discussed vertical scaling in detail in our previous video. You can watch it out there. We will discuss in detail about horizontal scaling, using about horizontal scaling of our individual shard, or about our individual shard. What is mean by horizontal scaling? It means using more instances for the same shard, for the same shard, right? Right? For the same shard. Suppose this is my shard Europe. What I can do? I horizontally scaled it. I created three instances for it. I created three instances for it. Shard Europe, Shard Europe. Like these are three machines individually for Shard Europe. These are three different machines. These are three different machines. Pretty good, pretty good. Now data will be distributed or user load, user requests will be distributed among these three machines. Earlier, it was being distributed. It was being received and queried by the same shard only, single shard only. Now we have three such machines, three such machines. Well and good, well and good. It will it now will be able to handle the user load more efficiently and in a more good manner. But tell me, how will we divide our data across multiple instances, right? How we will divide our data across multiple devices? Let me copy this architecture here. Okay, see, right? And for now, let's say instead of this, data is being served by Shard Europe. Shard Europe. Inside our database, it is being served by Shard Europe. Like the client is sitting somewhere in Europe and client is sitting somewhere in Europe or like whatever. We are again for your understanding, we are considering this this Amazon scenario where we divided our data based on the country. You can have another dividing mechanism also, but for understanding, let's we have divided our data based on the country, and user is somewhere sitting in the Europe, so its query will be served by Shard Europe. Okay, now we have three machines for Shard Europe. Okay, let me bring them. Okay, these are three machines. Okay, these are three machines, or I can write it in this way. Just a minute, guys. I'm trying to figure out how can we represent it in a good way. Yeah, this is a good way, right? This is a good way. Okay, now the data is being served by the Shard Europe. Now tell me, I made an order. I made an order of a cricket bat. Let's say I made an order of a cricket bat or a mobile phone. Okay, iPhone 18. iPhone 18. It has not been launched, but whenever it will be launched, I made an order for iPhone 18, and the request went to this server. The request went to this server. The request went to. Now on the next day, I want to check the status of my order. I want to check the status of my order. I again query. The query goes to load balancer, then server B. Then now this time, this query went to this shard. This shard. Okay. This will contain a orders table. This will contain a order table. But when we made an order, when we did a write query, the write was made in this shard. The write was made in this shard. But this time, when I am going to fetch the status of my order, the query is made to this shard. It doesn't contain my data. It doesn't contain my order data, right? So there is a problem with this. What problem? The problem is, how do we divide data across multiple instances? The data is, or the problem is, let me write it here. The problem with horizontal scaling of DB shard is that how do we divide data across multiple shard instances, right? When I did the right query, it went to this shard. It went to this shard. And now I want to check the status of my order. It went to this shard. So how the data will be divided or shared across these shards or instances, right? That is, suppose if we write in one shard instance, right? And read made in another shard instance, it will cause what? It will cause what? It will cause consistency issues. Consistency issues, right? It will cause what? It will cause consistency issues. Simply, it will cause consistency issues. Consistency issues, right? So now we want some good mechanism. We want some good mechanism to divide the data across these multiple shard instances, to divide the data or store the data across multiple shard instances. We want the mechanism so that if we made right query to this, so it gets efficiently replicated to other instances as well. Other instances as well. So here or where the concept of replication, concept of what? Concept of replication comes into the picture. This is where the concept of replication comes into the picture, that how we efficiently replicate our data across these multiple shard instances. So we will be going to discuss the replication strategies in detail in the upcoming lecture. In the upcoming lecture. So in today's lecture, what we did, we first understood what is DB server. DB server is what? DB server is just a machine that hosts our database. It can be EC2, MongoDB, Atlas, Supabase, RDS, or any other machine that hosts a database. Then we try to describe the strategies to scale it. These we have vertical scaling and horizontal scaling. Vertical scaling we described in detail in our last video. Then we moved forward with horizontal scaling. Before moving forward with horizontal scaling, we discussed DB partitioning. DB partitioning is what? Dividing your data across multiple partitions within the same database server, or dividing the data of a table across multiple partitions but within the same database server. Then we discussed the advantages of DB partitioning, that this way our search space gets reduced. This we call pruning. We can parallelly query the database, right? We can store a log. So if we don't want previous logs or earlier log, we can easily drop that partition, right? Then moving forward, we come towards the horizontal scaling. And in horizontal scaling, we discussed about DB sharding. That DB sharding is what? Dividing the data of the same table across multiple database servers. Across multiple database servers. This is database server one. This is database server two. It can be deployed somewhere. It can be deployed somewhere. Some data of the orders table is stored in this server. Some data of the orders table is stored in this table, right? Then we discussed about the differences between DB partitioning and DB sharding. DB partitioning, data remains within the same database server, but in DB sharding, We create independent and individual database servers and divide the data of a table across these database servers. Then we considered a case scenario of Amazon where data can be divided on the basis of country or country code. Then we discussed about this architecture. Now, your query will not be served by a single instance. We have multiple instances, and we have smartly created these instances, and each instance is called a child. Each instance is called a child. Okay. Now, then we discuss some instances, some challenges with these charts. What if any of these individual charts get burned out or gets pressed out? Then what we have to do? We have to individually scale these charts, right? Then again, we had vertical scaling in which we can add computing resources towards chart, right? But there is always a upper limit to it. Simply, then we discussed about horizontal scaling aspect of this chart, that we can horizontally scale this chart, right? We can create more instances of the same chart. But when then we discuss one challenges with this approach also, that what if right comes to this chart and we are reading from this chart. So we need to figure out some efficient mechanisms of the replication of the data to other charts as well. For that, we will be discussing about the replication techniques in our next session. Hope you enjoyed today's session. We will bring replication studies in next session. Until then, keep learning, keep exploring, keep yourself fit. Let's meet you in the next session. Bye bye.